Welcome to Hindustan College of Engineering Technology. In this video, we are going to discuss about vertical milling machine presented by S. Alagar, Assistant Professor, Mechanical. Milling process. Milling is a metal cutting operation in which the excess material from the workpiece is removed by rotating multi-point cutting tool called as a milling cutters. A milling machine is a machine tool that removes metal as the work is feed against the rotating multi-point cutters. The multi-point milling cutters rotates at a high speed and it removes metal from very fast rate with help multiple cutting edges. One or more number of cutters can be mounted simultaneously on the milling machine. This is the reason that a milling machine find wide application in a production work. Used for a machining flat surfaces, contoured surfaces, external and internal threads, surface machining, profile cutting, etc. Milling process. As the workpiece moves against the cutting edges of milling cutters, metal is removed in the form of chips. Machined surface is formed in one or more phases of the work. It should not completely make in a single object. It should be run in one or more times. The work to be machined in held in a vise, a rotary table or a 3-jaw chuck, an indexing head in a special fixtures or bolted machine table can be used to hold the workpieces. In many applications, due to its higher production rate and accuracy, milling machine has been replaced by a shaper, slatter or in a planer. It can be replaced. Vertical milling machine. In this topic, it is a major one. Spindle is a vertical or a perpendicular to the work table. It has all the movements of the table for a proper setting and feeding the work. Spindle head may be swiveled at an angle permitting the milling cutters mounted on the spindle to work an angular surface. In some machines, spindle can also be adjusted up and down related to the work. Why the vertical is more important? Comparatively, in other machines, it's going to be easily replaced. To make a face machining or in a profile or in a milling or in a surface machining, it is going to be very useful. That's the reason the industries preferred vertical milling machine. These are the major components of the vertical milling machine. So first one is base and one vertical column, and the vertical column is connected between the overhanging beam. The overhanging beam end is connected within a vertical head. After that, the head is connected within a chuck, milling cutters. These are the milling attachments. And next, base is connected within a knee steady. Knee is going to be connected within a knee. The knee is going to be elevated in a Z directions. And moreover, knee is going to be connected in a saddle. Saddle is nothing that it is a longitudinal wise movement. By using transverse table or in a transverse handle, it's going to be moved. Here, two type of transverse table is connected. So one is to move in a x-axis and one is moving in a y-axis. Knee steady is going to be elevated to get in a z-axis. At the same time, that drilling milling head, that means in the milling cutters to get a minor z-axis movement. So major parts: base, column, spindle, spindle head and knee. This is the realistic video of vertical milling machine. This is the base, knee, saddle and knees. After that, knees is going to be connected within a saddle. And saddle is connected within a transverse table. This is the gear mechanism to change the speed of milling cutters. Vertical column, and that vertical column is going to be connected within a overhanging beam. That overhanging beam end to connect it within a milling head. This is the transverse table wheel. Once it's going to be rotated to get in a Y axis. This is going to be get in a Z axis. The transverse table to connect it within a vise, because workpiece is held by using a vise, or otherwise These T slots can be used to make a hold the workpieces. At the end of milling cut, we are providing the milling cutters. Now I am going to connect with the pocket milling cutters. This vertical column and the base and knees can be made by using in a casting. Casting products most are preferable to use in the vertical columns and knees and base. Because to machining type to get in a high vibration. That vibration and the force can be withstand by using a high casting materials.
Now we are
going to fit in that workpiece to make a packet cutting. Otherwise, it is in a contour milling. Answer table is going to be rotated to get in a preferable place. After that, the milling head is rotated to get in a packet milling. The X, Y, Z axis can be formulated by using in the table movement. Z axis in a miniature level, it can be performed within the milling head. In a major level, we are going to use in the knees. Knee is going to be elevated in the Z axis. The milling cutter speed is going to be varied by using a different gear setting arrangements. So most of milling cutters is coupled with an electric motor. That electric motor converts into electric energy into the mechanical rotational energy. So in between, we are going to connect within a belt drive or in a gearbox. It's going to be improve the speed or to vary the n number of speeds. See the differences. We create a some kind of packets. Based on the milling cutter diameter, it's going to be varied. This is a major industrial machines because different type of machines, machining operations can be done within a vertical milling machine. The saddle is going to be moved. Transfer saddle is going to be moved in to get a second part because based on the milling diameter, to make a first cutting area is going to be removed and after that to remove the second part. Continuously machine in the whole entire area. In which area you need to make it a packet, that entire area is going to be moved. To create a packet milling. Or in other words, it is in a contour milling. Now the milling head is going to be moved in a Z axis. The workpiece is going to be removed. You see the differences. It's going to be machined in a packet milling. Next is the vertical milling operations. The operation is classified into n number of types, but in the major we are saying that plain or slab milling, face milling, end milling, side milling, slat milling, packet milling, form or profile milling. Based on the applications, it's going to be differentiated in a n number of types. So first we are going to see about the face milling. Face milling is nothing that it is carried out to producing a flat surfaces which is perpendicular to the axis of rotating cutters. Here is the video to make a surface machining. It's called as a face milling. So next is a end milling. End milling operation performed for producing a flat surfaces, key slats, grooves, finishing the edges of a workpiece to make a key vase. Next is a side milling. So side milling operation is nothing that it is performed for producing a flat surfaces, slats, grooves, finishing the edges of the workpiece in a side portions. So next is a slat milling. So slat milling is nothing that to make a keyway slats. It is in a T slat or in a I slat. It's called as in a slat milling. So next is a profile milling. So profile milling is nothing that to perform a special kind of shapes. It may be in a skeleton or it may be in a different shapes. It's going to be performed. In the outside periphery of a flat part is cut. Conventional end mill is used to cut the outside or inside the periphery of a flat part to get in a different complex shapes. And next one is in a packet milling. This is the real packet milling operation. We already saw that video in a real milling machine to make in a packet. Another form of end milling used to mill a shallow packets into the flat parts. Thank you.